Hey, what's going on, guys? Kins here. Last days I've been playing around with writing some toy text editors, and one of the recent ones I made a text editor with VI key abundance just to learn about how VI works. And since then I can't use any other editor than VI, to be honest, because it's really perfect in my personal opinion. But anyways, we're not going to be implementing VI anyways because it's quite complicated. And instead we're going to be implementing a text editor in only 50 lines of Python code. So that's the tightest version I could have came up with so far, and I just want to share that experience that I came up with, that I've managed to gain basically by writing that few text editors that I've been up with for the last couple of weeks, basically. And first, I would probably demonstrate how what we're supposed to be developing in this video is going to work. And it also would be possible to follow this tutorial on Windows as well, because thankfully to the Windows curses library, we're able to run this in the Windows command line natively as well. So without further ado, let's actually start. So it's called edit. Let me cd there, and I just say Python 3 edit.py, and here we go. Hey, what's up, guys? This is the text editor we're going to be building in this tutorial. So you can manipulate the cursor. The cursor wraps around like this. Okay, it doesn't go it's just the very last line here. It doesn't go behind the very last line. You can split the line by pressing enter in whatever place you want. Okay, by default the file name is no name txt, so if I press Ctrl S and then Ctrl Q and then list again, I have this no name txt appearing. So if I now say Python 3 and no name.txt, then I'm back and I can still edit in this file. So let me just do it like this, escape again, so it has been changed, right? And if I want to create a new file, let's say test.txt, and say this is a test, and like this, and we also can open this test, so this test also appears. Right, so this is how it works on Linux fantastically well. And now let me demonstrate you how this works on Windows. Yes, and I'm already in the proper directory. So yeah, here it is. And I just say Python and edit.py. Okay, yeah. So it's exactly the same thing. We still can manipulate our cursor, still can do the same things, right? And let's open our no name.txt, and it does open. And let's open the test.txt, and it does open as well. And we can even open its own source code, edit.py, and here's the source code that we're supposed to be writing in this video. That's it. That's very simple. That's very small. So now one last thing before we proceed actually starting writing some code. All you need to do is to say pip install. It's on Windows. On Linux you don't need to do anything. On Linux curses is the built-in Python library, but on Windows you need to say pip install Windows curses. I obviously have this installed already, but just giving you an idea how this can be achieved. So I hope this makes sense. Yeah, so I already have this installed, hence it's not installing anything. So yeah. Now, without further ado, let's actually start writing some code. Okay, so I create a new file called edit.py, and the very first line, I want to say bin python 3. So this will only work on Linux because I want to call this, I want to open this system-wide, but on Windows, if you just click on the file, it will just open the command line automatically for you. So you can ignore this line safely if you're on Windows. If you're on Linux and you want to later install this to user bin, for instance, then this line might be on the cards for you as well. Right, so first we need to import the curses and sys, and remember, so you should install Windows curses if you're on Windows to make this work. And we'll create the only function called main, and it would be taking the std screen as the argument. And now here, for now, we can simply pass, all right? And here we say curses dot wrapper and the main function here. So why this is done? This is done because if something goes wrong with the curses, it just won't mess up your terminal and would do everything nicely. It would properly exit and restore the terminal for you, so you don't have any issues using the terminal later on. I'm not sure if this is on the cards on Windows as well, but on Linux this is very essential. So let me just write this and say Python 3 and edit.py. And yes, so we do exit because it's not actually doing anything. So anyways, this is good so far. Okay, so now what I want to do is define the cursor screen. Actually, I didn't define the cursor screen, so it's not a surprise that nothing happens. So I say cursors dot init screen, and then I want to say screen dot no delay. So in order to so there is no delay when I it's like never-ending mode of listening to the keystrokes basically. So it just doesn't break. It just all the time listening for user input. So this is nice from the current implementation perspective. Then want to say no echo. So no echo is another part that like because we would be rendering the screen, we're not going to be like typing something and already seeing the output. So we're not going to be writing directly to the std out. We're going to be writing to what is known as the cursor screen. Then obviously we need to say cursors raw. So this is the raw mode. And also want to enable the keypad. So say keypad and 1. And this is it. Okay. Now let's actually try to run this again. Okay, nothing happens still, but yes, at least we do have our screen being initialized from now on. Now let's create the buffer variable. So B stands for buffer. So how is supposed to be representing our text? It's a dynamic list of lists. So every row in the text editor is the list of integers, and integers do represent the ASCII characters, and that's because the curses library itself, like when you read the character, it stores it as ASCII encoded integer. And we can't do strings because strings are immutable type. You can just change something in the string unless you're creating a new string every time, but it's not really convenient. So it's better to we have this. So we have many strings. Then within the one string, this is again a dynamic list of integers. So we insert one, we just insert, and it just is growing like appending to the end if we were the end of the line, or inserting in between, and so on. So I hope it makes clear soon. So then the source file. So let's call it noname.txt. Right. Then row big R and C. So this is gonna be the number of rows and the number of calls that are available within our terminal. So we can say screen.get max yx, and that's how we can actually like get how many rows. So by default this should be 80 columns and 25 rows. But anyways, whatever window you open, it would get that exact number. Later on, it's really easy to extend it to make like dynamically resizable. But we're not going to be doing this just for the sake of simplicity. Then then we define the variables x, y, which stands for column offset and row offset, and then current row and current column. And we initialize all of them to zeros, and in Python you can do it like this. So just initialize 0 4 times, and that's the fancy way to initialize these 4 variables to 0, just to save some space. Alright, so let's make sure it still compiles and runs. Well, not compiles, but anyways, you know what I mean. Yes, it does. So the next thing, I want to check for the command line arguments here. So I say if the length of the sys.argv is equal to 2. So this means that we actually do provide the file name when we're calling our editor. So saying Python 3 edit and then no name.txt or whatever file name.txt. So in this case, the length of the sys.argv is going to be equal to 2. And in this case, we can say that source is equal to sys.argv and index 1, which means the second element. So this is how we implement the, so let's call it save as feature. So we won't have the save as feature pre-built like from terminal interface, from the editor's interface, but we can say like edit py and then the file name that doesn't exist yet, and this would initialize the internal variable source from being equal to no name.txt to whatever you want, and then if you press Control S, it would save the bytes to that exact file. So that's the way how we can implement our save as function. However, it might happen that like by default it would be trying to actually open that file. And if that file exists, then great. But if it doesn't, it would throw an error. So we need to handle that as well. So here is a simple try except block. So here I can say that with open and sys.argv, and we're trying this argument that goes just right before the edit.py as file. And here first, we assume the good scenario. So we want to extract the content of the file. In that case, we say app.read, and want to split this by the new lines because we need to initialize the editor. And then we want either to get rid of the very last line if it's empty, but if we do this by default, then we're not going to be able to open the files containing the only line of code because it would be suppressed as well. So a little ternary operator here. So I say content is equals to content from the first line to skipping the very last one, in case if the len of the content is greater than 1. And otherwise, if it is actually equal to 1, then we can simply say the content is equal to content. That's pretty much all about it. Okay, so let's still make sure I didn't make any. Okay, curses wrapper, unexpected indentation. Oh, I just forgot to say except here, so just the run syntax overall. It's okay for now. So the next thing to consider, we actually need to populate the buffer with whatever we have in the file we're currently opening. This is one of the most essential things. So we can say for row in the content. So we do iterate over the rows within the content. So content now is the list of strings. And these strings are separated by the new line character, right? So every line is just like string 1, string 2, string 3, and every string is kind of like first line of text, the second line, the third line. It doesn't have new line characters at the end. Instead, it has just like one, another. So this is the list of strings at the moment. So we want to say buffer.append. And now I'm going to be using the list comprehension here. So I want to say ord c. So I'm converting. So ord is a function to convert the character to its ASCII code. So for instance, like the character A would be converted to 1997 if I'm not mistaken. Yeah. And so on. So to ASCII codes, because that's the internal representation, that's the exact format that we're gonna be taking from the get character command of the end curses itself. So it's going to be like returning the raw integers to us, not the fancy strings, because this is the very low level and this is the raw mod. And I hope this makes sense. So for a character in rows, so in this list comprehension, what we do, we loop over all the characters within the string, and we convert every character into its integer representation. And from now on, in the buffer, we no longer have a list of strings, but instead we have a list of lists where every string is represented as the list of integers, ASCII encoded integers, like for every corresponding character. So that makes sense. Okay, and now finally we can accept. So this can happen that the file above wasn't actually available, so it's like not found or something. In this case, we want just to append a single empty string to our buffer, because otherwise we'll try to run, or we wouldn't be trying to write to our buffer and would give us like index out of range error because there is no rows to write to, right? So that's the idea. And finally, another scenario that we need to handle, it might happen that user didn't actually specify the file to open at all, and in this case, to track this, we can say if the length of the sys.argv is equal to 1. In this case, we do exactly the same thing. We say buffer.append and the empty buffer. From now on, we're ready to start our loop that is gonna be like doing two major things to make this program a text editor. So the first thing is to render the screen, assuming the scrolling, so render like part of the buffer that we're interested in, and then the second one is to read the user input. So that's pretty much all about it. Okay, now before we proceed, let me just try and run this again to make sure. Yeah, now finally no errors. So far so good. So now we can actually start implementing our main loop. All right, so the main loop, I'm opening the line here and say, well, true. My favorite thing. And now let's define the character that is going to be equal to -1, and we can say while character is indeed equal to -1, and that's, by the way, because of the no delay mode that we've considered. So if you don't do anything, if you call the get char and you don't press any keys, the get char would be returning -1. So that's the way how we wait until it actually returns some actual key press, and not just idling, like waiting for a key press. So here we can say character, like char is equal to as.getCharacter. And obviously if we leave things like this, it's not going to work because we will stuck in the infinite loop. So here we need to say if the character is equal to and I'm converting the character to it's already like in the ASCII encoding. So if we want to match this with, say, with Q, we first need to convert this Q to that ASCII representation. So again, our ORT function is on the cars here. So ORT Q, and we want to bitwise end with 1F. And this actually helps to track whether not just the Q, but the control Q has been pressed, because we can bind this to Q, because in this case, every time you try to type Q in your text editor, you would just escape from the program. Hence the control Q to escape from the program, to escape from the editor. So in this case, if character is equal to Q, we simply say sys.exit. And we're done. So now let's quickly check this. So if I did everything properly, now should gonna stuck in the loop. What? Invalid syntax? What did I do wrong? Oh, it seems that I just forgot to put the colon there. Okay, so line 15, go into line 15, and yes, insert mode and colon. And again, yeah, so now we were stuck here, so I can type something, nothing happens, but if I press Control Q, we're back to the terminal, which is great. So from here, we can actually start implementing our loop to render the screen and to handle the scrolling. We'll start from handling the scrolling, and then we'll try to print our buffer. And from there on, we'll be able to actually open some files with the editor. Well, actually, we can try to open the file already. Let's try to open its own source code. Nothing happens, but yeah, but it doesn't give an error as well, anyways, which is cool. So rendering of the screen should always start from putting the cursor into the top left position of the screen. So I can say as.move 0, 0, right? And then we will be handling our scrolling. So the idea behind scrolling is very simple. Let's say we have a big buffer and it's bigger than our screen, the 24 rows of our screen in height, and it's also, let's say it's bigger than 80 columns in width. So this means that we have a small frame that can be scrolled over the text vertically and horizontally. So we'll now write some code that would actually allow us elegantly perform this scroll. So we say the following thing. I can say if R, which is the current row, if the current row is less than Y, which is the row offset, so if row is less than the row offset, in this case, we set the offset equals to row. Then we can say if the row offset is greater or equals than if current row is greater or equals than row offset plus big R is the height, how many rows is available in the terminal. So in this case, we say that the offset, row offset, is going to be equal current row minus and the number of rows available in our terminal plus 1, right? Then and these two lines already managed to already allow us to handle the entire vertical scrolling, believe it or not. Now let's deal with the horizontal scrolling. So I can say if C, which is the current column, is less than the column offset, so this is X variable. In this case, we simply say that the column offset is equal to the current character. And also we say if C is greater or equals than the column offset plus the number of columns available in the terminal. In this case, X is going to be equal to current column minus the number of columns available in the terminal plus 1. So this is the scrolling, believe it or not. And from here, we'll now go implementing the, let's call it the print buffer function, even though we're not separating this as the function, but still, if you want to separate the functions, then the upwards 4 lines can be called like scroll buffer, and the next lines we're going to be writing now might be considered as like print buffer, for instance, if you like. So I can simply say for row in range, and the range of how many rows we have in our terminal. And now we want to calculate the actual buffer row that we need to display assuming the current scroll. So we'll call this variable buffer row, which would be equal to current row plus the Y offset. So I hope this is self-explanatory. And exactly the same thing we do for column. So I can say for column in range of how many columns is available out there. We create the buffer column that is going to be equal to current column plus the column offset, which is stored in the variable X. And now what we need to do is to try to print a character. So the reason why I'm using try here, well, is because in curses, for instance, if your cursor is at the very last column and you just try to type something, it would throw an error because it just goes outside the window bounds, and the same applies when you're trying to write trying to consider the new line when you're at the lowest row as well. So the general idea for not being bothered much about this is just to wrap the add character function call into the try except, and that should be fairly enough. So I can simply say screen.add character, and I want to add character at the current row, which is the screen row, and current call, which is the screen call. However, what we actually, the character that we're sourcing is taken from the buffer, obviously, and from the buffer, we're not doing this from current row and current column, but instead we're doing this from buffer row, which calculates the offset as well, and the buffer column as well. So this line would actually bring some text onto the screen, believe it or not, which is nice. And here we just accept and pass. And then, important thing to avoid some nasty glitches, we want to clear everything goes from where the cursor is when we ended up printing the content of the line, and to the right. So from the cursor to the end of the line, we want to clear whatever is there. And this mostly needed for delete when we're going to be dealing with the delete. So deleting just moves the text, but if you don't clear the line, it would be just whatever text was there would still be in the screen memory. So we want to avoid that. So in order to avoid that, we can simply say screen clear to end of line, and this is it. And from here, all we need to do is by the end of every screen line, the screen buffer line. So we're literally we are implementing our own custom screen buffer here. So by the end of the screen buffer, we want to add the new line character. So I can simply say try as dot add character, and the new line character, right? And accept and pass. And at this moment already, if I did everything properly, we should actually be able to see the content of the file if we load this with the editor. So let's actually try it. So if I say Python 3 edit Python, and let's try to see the source code of the editor that we just written. So edit.py, and indeed you see like we see the content of our file. We can't yet manipulate the cursor or doing anything because it's not yet supported, but anyways, we can already deal with this. Now to bring a bit more fun here, I can demonstrate, like, so you see that currently the cursor is at the very end of the last line. We'll put the cursor to the actual cursor position later on, but let's say we'll now try to manipulate the cursor position. Well, actually, yeah, we can still scroll a little bit. I believe I just want to demonstrate the scroll like manually. So let's press Control Q. Okay, and if we drop back here, yeah. So there is a plenty of room for scrolling already here. So I'm just thinking, where should I put the cursor to? Yeah, for instance, so yeah, it just goes to the current row, current cursor. So yeah, for instance, I just opened the line here, or probably even here, open the new line, and I say that row is equal to, let's say, I'm not sure how many, let's say 24. Yes, and well, column. I can show the horizontal scroll because it fits the width. I'll demonstrate that later. So yeah, it's like this. So it now should be in a different position. Oh, it's actually not really. Trying to add a character. Yeah, probably a bit more. So let's try make it 28, for instance. And yes, so you see, like we now just scroll a little bit more. So it's already not from the very beginning of the file. So again, like if I just put this back to, if I put this back to 0, then we have the file from the very beginning. So I hope this makes sense. It's not really that intuitive at the moment, but when we're going to be able to move the cursor, hope it starts making more sense. Okay, so we no longer need this experimental initialization for row and column, and instead, yeah, I'll continue this line because remember we want to fit the 50 lines of code. So now every time, so the first important thing to consider is to bear in mind is that when the screen is actually getting updated. The screen is getting updated when the user presses a button. So before you press the button, there is no need to update the screen because nothing really changed there. So if you do otherwise, you just might end up having some flickering. And when you do press the buttons, that means that the cursor position of the row list can change, or if you insert or delete the character, the buffer's content can be changed. You need to re-render things, and also you need to re-render the cursor position. But the problem is, you've seen that the cursor, by the end of printing the buffer, it finds itself in the very bottom line after the very last character being printed. So we need to bring cursor back to its current coordinates, right? And in order to make it smooth, we want to hide the cursor before we move in the cursor. Although it might not be 100% necessarily needed, but it just feels a little bit better with that sort of a thing. So I can simply say cursor set, so it's called cursor set 0, which means I hide the cursor. Then I move the cursor to as.move, and I say row minus y and column minus x. So we need to make sure that we do subtract the row offset and the column offset from the current R row and col values, which are the absolute coordinates of the cursor relative not to the screen, again, like it's relative to the buffer, but by saying minus y and minus x, which is minus row offset minus column offset, we convert the cursor position relative to the buffer to the cursor position relative to the screen, and that's really important. How that makes sense. And after we did this, we actually can turn the cursor back. So I can say curses dot curse set. Oh, what have I done? Curse set back to 1. And in order to apply these changes, we need to refresh the screen. So I say screen dot refresh, and that's pretty much all about it. Great. So now the difference, as opposed to the previous example, would be that after we print the entire buffer, the cursor would move back to 0, 0, which is its initial coordinates, because we didn't yet press the arrow keys or something, so we didn't yet manipulate the cursor, and the initial coordinates of the cursor are like this, 0, 0. So let's actually figure out if this is true or not. So, and indeed, you see, like now it prints the buffer, but the cursor already is in the top left corner, which is exactly what we've been looking for. Great. Okay, so now we're ready to start implementing the cursor movements, basically. So what happens if user presses the arrow key, for instance? So let's implement that as well. Yeah, this is the line. So just write below this while. I'm opening a new line here, and I can say if the character is equal to, and here I'm using the cursor's constant. So this constant works both for Linux and Windows. It doesn't for enter key. It doesn't work for Backspace. So those we would be handled manually to make this being compatible for both Linux and Windows. But as for arrow keys, fortunately they work. So if character is equals to curses, let's actually start with the key right, because we won't see, we're not going to be moving left from the 0, 0 coordinates of the cursor. So here we say if the current column where the cursor is currently at is less than the length of this entire row within the buffer. In this case, we can proceed one space to the right, so one position to the right. So in code, we can say simply if c is less than the len of our buffer row. In this case, all we need to do is say c plus equals 1. And another nice feature, nice option, we want the cursor to wrap around. So say we are in the very last position within the row. So start of the row, end of the row. So we go, and then we want to go to wrap to the next row. So in order to do this, we need to check whether we didn't exhaust the buffer length. So there is still a row down below where we can do. So we can ignore this for the most rows, but for the very last one, we need to make sure that it doesn't go beyond the length of the buffer, for otherwise we'll have an index out of range error. So here we can say elif and row is less than the len of the buffer minus 1. Okay, and in this case we also say row plus equals 1, meanwhile putting the initializing column to 0, because when we wrap we want to go to the very first to the very beginning of the line. So that's it, and now we should already be capable of so now press the right key and we go into the end of the line and we're jumping to the next line. So far so good. We didn't yet test whether it actually goes, and it's like just try to scroll, which is good. Yeah, so we're trying to, well, it takes a little bit of a time. So probably I would rather implement like other keys first, and then we'll test that it doesn't go beyond the very last line. So yeah, now let's actually implement the left key. So here I can already say elif, because we'll start with if character. Later on this if would be when we insert the character actually, but for now just might be like this. If character is equal to curses dot key left, it's quite similar to what we've done so far to the key right. So here we say if current column is not equal to 0. So if it's like if we move to the very first character, so only in this case we want the character minus equals 1. So here character column minus equals 1. However, otherwise, if indeed we have this 0, but the row is greater than 0, so we're not on the very first row, but at least on the second one or third or something. In this case, we can also say row minus equals 1. While the column is going to be equal to the length of this new buffer row that we've just landed on. Okay, so right quit, and let's make sure. So we're going this way, and yes, we're going this way. So I'm pressing the left arrow key. So say like we go here, and on the first line nothing happens. Yeah, because we just there is nothing else in the buffer, so we can't really go there. All right, so now we have the left and right keys being implemented. Now it's time to implement the up, going arrow up and arrow down. So let's drop back to the editor, and yeah, here, opening the new line, and here, so I say elif character is equal to curses key up, right? Well, actually, nope. We'll do this a little bit differently. So key up, and the row is not equal to 0, so it's not the first row. In this case, we want to say row minus equals 1, and elif character is equal to curses key down, and row is less than the length of the buffer. So we need to make sure again that we don't exhaust the length of the entire buffer. This is pretty similarly to the above code when we've been handling the wraparound for key right to not go beyond the last line, and the first line for key left. It's fairly same thing, and here plus equals 1. And well, it's already good enough for demonstration, but we'll need to add a few more lines of code to actually fix the bug that we've just made. But anyways, I just want to demonstrate. So what? Invalid syntax? If character, yeah, sure it is. There should be 2. Okay, insert like this. Okay, so now, sorry, just trying to move the cursor with AJKL like in VI. So now we can go down and we can go up, but you notice the problem. So here, for instance, we go up where the text buffer doesn't exist. So in this case, we have the miscoordinated position of our cursor relative to the actual existing locations in the buffer. So one of the following things. So if we go up, then the cursor should drop here. If it is within the length, it's okay. But if we go up and it's just greater than the length of the line that we're jumping to, that it needs to go to the very last position. So now let's actually implement that as well. So going back to the editor and add the following lines. So here I can say, so first we need to get the current row. So we say row is equal to the buffer row. And we actually need to make sure whether this row exists or not. So I'm using the ternary operator here. So row is equal to buffer row in case if row is less than the len of the buffer. So make sure it is within the buffer, the row is within the buffer. And otherwise, it's none. So the row would be either the row or none. So if it's none, this means that the row doesn't exist. So we're not going there. Then we need to get the row len for this row. So row len is equal to either the length of this row that we've just made, in case if it's not none. So if row is not none, and otherwise the len is going to be equal to 0, right? And well, this is good. So we might encounter such lines. We might encounter empty lines within our buffer. So in this case, where to put the cursor, we put them to 0. So I hope that makes sense. And now we can say that if column, so like if current column is greater than the row len, so which I have just been demonstrating. So we're just going up with the cursor, but it's just longer. It's bigger than that the length of the row. So length row here, we jump here. So nope. So in this case, we actually need to override our column and say the column is equal to row len, rw len. And this, believe it or not, is already enough to wrap the cursor properly. So yeah, I'm trying to use hjkl again for move the cursor. So okay, you see what happens now. So so while it's still within the length of the row, like here, but if it goes like, it's not going like just up, it goes to the end of the next line here. So it's okay, and here it goes again, here it goes again. All right, so now we can actually scroll. Okay, and I promise to check whether moving right is working properly, and indeed it does. So now we can navigate through the entire thing. Yes, you see like the cursor would be automatically adjusted its position. Yeah, and well, I didn't show what happens if so here we have all the rows, but in case if the row length was going to be equal to like nothing there, in this case we just drop to 0 and start going from there. Let me actually probably demonstrate you this. So let me just add some line here, and again, so here we go, and bam. Oh, actually it's auto indentation. It's auto indentation. So yeah, because of the auto indentation, yeah, this is just actually trying to delete the auto indentation there. And yeah, now you see like it drops to 0 and goes from there on. So yeah, that's kind of how it works. Well, now we can officially turn our text viewer into the text editor. So let's implement insertion of the characters. So I just drop back from here, going back to the editor, and here again, like I can finally make elif here and here. What we want to avoid is if user presses like control and not control Q and not control S, that would be binded to the control Q is already binded to quit, control S would be binded to saving the file. But if say user press control whatever else letter but not S and Q, it would potentially result in printing some gibberish onto the screen. So we want to avoid this, and we want to make sure that if we are about to be inserting the character into our buffer, that control key is not being pressed. So hence the following code. So we can say if character is not equals to character bitwise ended with hexadecimal 1F. So that's the same code that we use to track the control Q, right? So it's not, the control key is not being pressed. And I also want to make sure that the character is less than 128, so it's not going like to whatever like upper keys. Like, so if you press something like and home or whatever, most likely nothing happens, but just to make sure that no unwanted characters are there. In this case, all we need to do, we want to see the buffer and the current row. We simply want to insert the character there, so we insert at the location of the current column, and we insert the character itself. And after this, after we insert, obviously we want to increase our column. And this is pretty much all about it. So from here, we should already be capable of inserting text into whatever. Okay. Oh, I'm still okay. I'm sorry. I'm still in the VI. Right. So yes, now we're able to insert the characters. We can't enter, we can't delete for now. So for now, it's just like only the insertion, but within the current given line of code, we can insert whatever we want. Great. So the next thing to consider is, well, let's implement the enter key. So what should happen if user hits enter? So elif. So now the next thing I do, I'm converting this ASCII encoded integer into the string representation. Well, that's done for the reasons of compatibility, not only for Linux but for Windows as well. So on Linux, I could have just do like curses key enter. So if character is equal curses key enter, but this won't work on Windows, unfortunately, for some unknown reasons, because Windows curses for some reason doesn't do this. So we're gonna be manually matching the characters. So it's within the range of either the new line character, and this works on Linux, or the carriage return, because on Windows the enter is the carriage return. So the ASCII code on Linux is 10, which is the new line. The ASCII code on Windows is 13, which is the carriage return. So if we have this character within the range, like either carriage return on the new line, in this case we want to do the following code. So you remember that if you press enter somewhere in the middle of the line, we actually break the line. So L stands for line here. So buffer indexed by the current row, indexed by the current column, from the current cursor position, and whatever goes to the right of the line. So we store it into the variable, right? And then we need to we need to chop whatever goes to the right. So the next thing we do, we'll chop the what goes to the right. And since we want to store it first, we don't want to lose it. So we first store what goes from the cursor to the right, and then we actually chop it. So to chop it, we say buffer within the current row is equal buffer row, and whatever goes so until the current cursor position, we remain. So here we just take the left part, and the right part has been chopped from now on. All right. And next thing we want to say row plus equals 1. All right. Column is going to be equal to 0, because when we press enter, if there is no auto indentation, we definitely go to the 0, right? And now we want to insert a new line into the buffer. So we can say buffer.insert where the row is, so where the current row is, and we insert an empty line plus whatever we stored. So whatever was to the right of the cursor is this line, and in Python we can just concatenate this to arrays like this happily, and this eventually should be fairly enough to have our nicely working enter key. So let's give it a try. So somewhere here, and ban, and ban. So we got it. right? Also, obviously, if we just do like from here, enter is also working, so we're not appending anything. But if we want to press enter here, then we do, and yeah. So this is exactly the behavior of the enter key in the text editor. And the next thing to consider is the backspace key. So it's quite similar to what we've been doing so far. It's quite similar, and the only difference is we need to do this in a little bit of the reverse order. Now, in order to track the delete key, it's also not that trivial because of the compatibility in both Linux and Windows. So in Linux, you can just say if character is equal key backspace, but on Windows, actually this key backspace on Linux, on my system, it's the integer number 263, while the casual one, like casual backspace for the ASCII code for backspace character is 8, and unfortunately it just doesn't work on my system with 8 on Linux. So to track both, I can simply say elif and character in the range from this 8 and 263. So again, like 263 works for Linux, 8 works for Windows, so this should be fairly enough. And now, if the column is true, which means that the column is not, so the cursor is not at the edge of the screen, but somewhere here, for instance, so it's like at least position 1, so not 0, but position 1. In this case, delete is very simple, so all we need to do is to say character minus equals 1, and then we want to delete within the buffer row, we want simply to delete the current character. That's pretty much all about it. We can already test it. So let's go, and I say delete, 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 and we drop here because nowhere else to go. So we didn't yet implement the wrapping. Now what we need to do further on. So let's say if in this position, if I press delete one more time, so the previous string should append whatever goes from the current cursor position and to the end of the current row. So we need to concatenate the previous string with the content of the current string. So let's do that in code as well. And yes, I just go down below here. Yes, right over in here. So otherwise, I say elif if row exists. So this is important. And now again, this time we want to save whatever goes from the cursor to the right. So it's actually fairly simple, fairly similar like we did in the previous part. So we can say line is equal to buffer row, and from starting from the current cursor position to the end of the line. This is important. So storing exactly the same like we did for a new line character, but then it goes the following way. So we delete the buffer row. We delete the entire buffer row. Okay. Then we say row minus equals 1. So going one row back. Then the length, then we need to adjust the position of the column, so like we did when we were wrapping with left button. So C is going to be so cursor, the column should be the length of the previous buffer row, like this. And finally, this previous buffer row, so once we delete one, so the previous starts being the current, we simply say buffer, this new buffer row is just simply equals plus equals L, that the content of the previous of what we have in the previous line from the cursor to the right. And yeah, so it's be much easier to actually demonstrate rather than to explain apparently. So ban, and we got it. So whatever we had, so from here and to here, it gets stored, and then the first line, like the previous lines, becomes the current line, and we do append whatever we had there. But if there is nowhere else to go, in this case, it's just not going to be working. So this is how it works. Yeah, and actually by this time, this is the entire text editor. But you might be wondering, we didn't yet, we still have only 47 lines of code, not 50. So one last thing that we're going to be implementing in this text editor is the save feature. So what essentially save is, we need to convert the buffer into the text, into the single string literally. And then that single string is about to be written to the file. That's pretty much all about it. Right now, just to make sure that we indeed have 50 lines of code, we need to get rid of this test line. So we have four more lines to implement our search. And we will implement our search just right below this quit thing. So here I say elif, the character is equal to ord s bitwise ended with 0x1f. So Control S. What we do in this case, so let's create again the content variable, which would be storing the entire buffer content as a single string. For now, it's simple. It's equal to the empty string. Now for a line in buffer, so we loop over all of the lines in the buffer, and we say content plus equals. Now we want to join. Well, actually, let's start by the list comprehension. So we want to convert to the character for C in line. So every character in line, we want to convert this from integer to string to character, right? But this is still gonna be just the array of characters, not the actual string. So to convert this into a string, we need to say join. So insert. I want to join this. All right. And also, since we don't have the new line characters in our buffer, and while we do turn this buffer, this list of strings into the single string, we need to separate the lines with the new line characters. So I just append the new line character at the very end. And you see now, like, we already have 50 lines, and now we'll write the very last line of code here. So with open, and whatever source variable holds, want to write to the file stream as file, and simply saying f.write and whatever content variable contains. And this is pretty much all about it. So now we will go and test this so whether it's actually capable of writing the files. So write quit, and let's start with yes, actually it seems like I deleted the files. Yeah, so let's say python 3 edit.py. So by default, if I type some gibberish here and do whatever I want, like, and just, yeah, and I press Control S, it should store file as no name txt, and indeed we have this no name txt. So we can look at with cat, for instance. It's Linux command. You don't have it on Windows, but anyway, so this is our text. But obviously we can still say edit and no name.txt, and we're still editing the same file, so we can add some fun content here and save Control Q, and it's already there. So far so good. You know, let's sort of a save as. So we want to create new files. So let's call it test.txt, and hey, what's up guys, Code Monkey Keys here. Monkey Keys here. Did you like this tutorial? Like and subscribe if so. Cheers. And if I did everything properly, it now should create this test.txt. So opening test.txt, and we have our text. This is it from my side, guys. I really hope you loved the tutorial. So see you next time. Until then, and take care. Oh, just noticed horrible mistake, obviously, like this.